Welcome to another edition of ProSoft video training. Today we'll be covering our new PLX50 PBM module. This is a ControlLogix PROFIBUS DP module. This module fits directly into a ControlLogix backplane, providing a PROFIBUS DP interface to devices such as HMI, drives, and I/O blocks when operating as a DP master. Additionally, through the use of third-party DP to PA couplers, the module can talk to PROFIBUS PA devices as well through the use of a proper coupler. The module also supports the ability to be configured as a ProfileSDP DP Slave, which in instances such as that, the PLX50 PBM module will sit on a network with drives, HMI, I/O blocks, and pass information from a ControlLogix processor up to something such as a Step 7 Siemens processor. The module provides support for up to 5,000 bytes worth of input and output data. The module can operate as a master, a multi-slave, or in quiet mode. And one of the key benefits of operating in a multi-slave mode is every PROFIBUS DP device is limited to 244 bytes maximum of cyclic I/O data. With this module being able to emulate up to 10 individual nodes on a PROFIBUS DP network, you can quickly transfer up to 2,440 bytes of cyclic I/O data. The module supports up to 11 I/O connections to the ControlLogix processor. It is supported in our PLX50 configuration utility, and then also has an optional SD card for disaster recovery. Some of the key benefits is the module is integrated with Studio 5000 with the add-on profile, and you can launch the PLX50 configuration software from within the add-on profile. And the support for up to 11 I/O connections provides you with high-performance PROFIBUS module for large PROFIBUS DP networks needing to transfer a lot of data back to a ControlLogix processor. Within the configuration utility, we've got the ability to export custom L5X files that can be imported into your Studio 5000 environment. This feature right here helps minimize configuration and setup time and get you up and operational quicker. And we also have within the configuration utility a PROFIBUS DP packet capture. This allows you to troubleshoot without requiring additional hardware on the network, being able to look at PROFIBUS DP packets and your communication with various devices. So that's a basic overview on what the module provides. Let's begin with the first-time setup of the module. First thing we'll want to do is come to our website and download the files that we need to begin. You can get all the files off of www.prosoft-technology.com. Go to the search window here. You can enter your part number, PLX50-PBM. Pull up the product page. Come here to our download section. For this video, we're going to need two things. We're going to need the add-on profile, and we will need the PLX50 configuration utility. So the configuration utility, if you have a previous version of the PLX50 configuration utility, you will need at least version 1.017 for the PROFIBUS module. And so that's it on the website. Let's begin. First thing we're going to do is open up our PLX50 configuration utility. In here, we'll select File, New. That will open up our Project Explorer window, where I can just go ahead and either select Add a New Device from right up here, and that brings up my device menu. And I'm going to select the PLX56-PBM module listed right here. Click OK. Under the configuration here, I've got an instance name. This can be changed to whatever I want. I can set that however I choose in there. I also have the mode for either a standalone master, a slave, or quiet mode. In this example, we're going to be setting it up as a standalone master. Under our PROFIBUS configuration, this is where we would go ahead and set our station addressing as well as the baud rate. And so by default, the baud rate's 45.45. I like to utilize a baud rate of something like 1.5, and so I'll go ahead and set that to the 1500 kilobits per second. Most of those other settings in here, these are timing related settings based on the PROFIBUS network speed. I recommend that we leave those to auto recommend. This will allow the module to automatically adjust the timing based off of what baud rate you selected. Next, we'll click on the Logix tab. And under the Logix tab, this is essentially where we set the number of I/O connections that the module has. This module utilizes multiple I/O connections with the ControlLogix processor. And so you can set it up from anything 1 I/O connection to up to 11 I/O connections. The number of I/O connections also determines the update rate. So anything between 1 and 4 I/O connections, you can set an RPI time as low as 2 milliseconds. Anything above 4 I/O connections, you need to set your RPI time to 10 milliseconds in the PLC code. So for this example, I'm just going to set a single I/O connection. Our Logix base tag, this is basically what slot number the module is going to be in the processor. And this is useful for when you import your code. And so I'm going to go ahead and put a value of 1 right here. I'm going to put the module in slot 1 of my PLC rack. I'm going to click Apply here, and OK. So that's the configuration for the module as from a ControlLogix perspective. Now to configure the module on the PROFIBUS side, select PROFIBUS devices, click on Add PROFIBUS device. This will bring up our window that shows us all of our available PROFIBUS devices. We have GSD files already loaded for some common ProSoft products, but we'll need to add some GSD files based on your project. Click on Add File, select the GSD file that you want to add, click Open, and you'll now see that you have a new GSD file that's loaded into your catalog for, in this case, a Siemens CPU 1510 SP. Another way that you can go ahead and add additional GSD files is through the Tools menu by navigating Tools, GSD File Management. Here you can see all the GSD files again. Under Catalog, you can import or export and rebuild your GSD catalog through this window. So say, for instance, you had a large amount of GSD files on another computer. You could export those files and then import them into this computer and then just rebuild your GSD catalog. So now when I come over here, I can come back, add PROFIBUS device. You'll notice I now have my Siemens CPU. I can go ahead and add that into my project here. And then under my device configuration, I could set my station address. This is the node address of the device on the network. And so in this case, we'll set that to a value of 9. You've also got some other options for freeze and sync and group memberships. I'm not going to go through all those today. And so the main part when adding a device is really the slot configuration. This is where you define what PROFIBUS devices are on the network. And so here with a Siemens Step 7 device, they have some placeholders for config for slot 1, config for slot 2, config for slot 3. And then now I can go in and I can add something like 64 bytes input total length. And that goes ahead and maps over my data that I'm going to receive from that device. From this window, you can actually go ahead and change information here. And so say I want to modify this tag. I could say S7 data tag. And what this will do is actually set up our tag that we're going to import into our Rockwell software. So that would be the setup and configuration of something like a Siemens device. You can go ahead and click OK. I'm going to add another PROFIBUS device on here, and I'm just going to add one of our ProLinx modules and go under the PROFIBUS configuration, set the node address, come over here and under the slot configuration, and I'm going to add a module. And here I've got an input module, 16 bytes of input. Again, one of the things that we can do is we can change this tag right here, and I can call it float data 1. I can tell it it's a data type of a reel, and that will go ahead and change how my data gets imported into project file. And then I can come through here, and since I've got 4 floating point values that are coming from that device, I could go ahead and set this, and float data, I'll call it now 3. You have to, when you're doing something like this, I pulled 16 bytes worth of information. So when you're generating your tags, you'll need to make sure that you're generating up to 16 bytes worth of tag data. So, but this just helps with as you're importing, and I'll show you in a minute what this is going to look like when we import it into our Studio 5000 program. Back through here, and I would go ahead and click OK on this, and that now goes ahead and generates those tags. So next I would need to build my project file, and so if I click on the right mouse click, I can go ahead and generate Logix L5X. So this goes ahead and builds our file. Another thing that we can do is look at this mapping report right here. And under the mapping report, it's going to tell us how many bytes of data is reserved for each device, and it's going to tell us how many I/O connections. So right here it says requires one connection. If you go in and you try to verify your mapping and you don't have enough I/O connections, that's where you would just come back in here under the configuration tab, select the Logix, and increase your number of I/O connections right here. But right now we want to go ahead and export, generate Logix L5X file. So let's go ahead and do that. And I'm going to go ahead and generate this file right here. And then the next thing we need to do is download this file to our module. And so I'm going to go ahead and set my configuration or my connection path. And first of all, I'm going to browse for some devices on the network. I'm scanning for Ethernet IP devices out there. And unfortunately, I'm not seeing my Logix controller that I wanted. So, so what I'm going to do is I'm going to go ahead and enter this in manually. Sometimes that will occur due to firewall settings, or I'm utilizing a virtual machine, so not everything shows up in there. But I'm going to go ahead and type in my IP address. And so here's my, the software was able to find that Logix controller. And then it also was able to see that in slot number 1, I've got a PLX50 PBM module there. So I'm going to go ahead and set that as my connection path there. Click OK. And now I'm going to go and download this file to the module. I've downloaded the file to the module, and as you can see, nothing is communicating right now based off the red. And now we need to go into the Studio 5000 program and fix that. Next, we're going to come back to Studio 5000. We've got a blank project that I just opened up here. And so the first thing I'm going to do is come in and add my new I/O module. So click New Module. And I can go ahead and filter by ILX, and it pops up right there. Now remember, this is the EDS or the add-on profile that was installed prior to starting this session. So if you don't see that catalog number in there, make sure that you've installed the add-on profile. And so now we go ahead and click Create. Can go ahead and give the module a name. I'll just call it PLX50 PBM. And under this Change tab right here, this is where we can go in and set the number of I/O connections for the module. Remember, this needs to match what we've defined in our PLX50 configuration file. And so you can select between 1 and 11 I/O connections here. Under our PROFIBUS DP configuration, you can go ahead and we can go ahead and launch our PROFIBUS DP configuration software from this tool. So that is also an option right there. I go ahead and I click on OK. That will allow me to create the module. And this module is in slot number 1. And now if I come over here, PROFIBUS DP configuration, I can either type in a name here, and if you type in something, it will tell you to create that file, or you can go and browse and find that file that we created in the step just before. So you can go ahead and browse, assign that file, apply it, and then if you launch this PROFIBUS DP configuration window, it will take you back to the PLX50 config software. So I've got my module defined here in slot number 1. The next thing that I want to do is bring in my new routine. And so as part of the configuration, we go ahead and export and add import routine. There's a routine that was that L5X file. So I'm going to go grab that L5X file that we created here, and I'm going to import this routine. The file name, or the name, is going to be my PLX50 PBM. That matches what's in the PLX50 configuration software. Your tags right here, it's going to go ahead and bring in the tags. Since we've already defined the module, use existing for your local I/O tags. And then it's going to create a couple of tags for our PROFIBUS slave devices right there. So we'll go ahead and click OK there. This will go ahead and create our routine. And the only thing now we need to do is add a jump to subroutine here for our newly added add-on routine. And that will be it. Verify our project, everything's good. And I'm going to go ahead and select a device. Here's my device. And I'm going to download to that controller. And once I download, I put it back in run mode. And so that is now in run mode. Now, to go in and actually enable communications on the bus, we need to come in here, open our local controller tag here. And as we can see right here on our input, we've got some status information that lets us know number of active devices, whether or not the PROFIBUS is in operational or offline. So right now we're currently offline. And to go ahead and put it online, we would open our output image, and we need to place a value of 3 in here for the command control. That will go ahead and place the module on the network and start communicating with devices. And so we've now got that offline bit has cleared. We're now operational. And so now we can look at our information. These are the tags that were created as part of our import routine. So we've gone ahead and created tags for, there's basically some output tags that sets the station number and a device CRC. And we've also got some input tags here that goes ahead and sets our data. So this was the floating point data tags that we created in the configuration software. So it automatically imports and brings those in with the data type that was specified in the configuration file. Now, the module is online trying to communicate on the network, but there is one other thing that we needed to enable. And so in my output, I put the 3 in there for the command control. That puts the module on the network. But I also need to turn on my individual slave. And so I want to go ahead and enable data exchange with slave number 10. That's one of the devices I defined in my configuration file. In the configuration file, I actually defined both device 9 and 10, so I'll turn both of those on. And now I've actually started to communicate, or I should have started communicating with that particular device. And so I can come over here and I can look at my PLX input, and I'll notice that I'm getting data updates on the point. I'm simulating data off of that. So I'm now communicating, everything's up and running. So now that we've got our PLC code and our configuration file, come back over into the PLX50 configuration utility and just show you a couple things in here that you can actually look at. So you do have a status information tag while you're online. You'll notice that these boxes are green when you're online. If you don't see those as green, it probably means like this, you're in an offline state. So you can just go ahead and select to go online. It also shows you immediately, we can see that we've got a red box next to node device 9, and then a green box next to device 10. What this shows you is a really quick indication of we've got valid communications with device number 10, and we are not communicating with device number 9. A reason for that is I don't have that device on my network right now, and so I just wanted to put that into the configuration file to just display it, but I do have device number 10 out there. Under the status, you can come in here and look at the status information for the module. It'll show you everything from the uptime on the module, whether or not you've got any PROFIBUS device errors, any of your general statistics like transmitted packet counts, some of the different frame messages that are on a PROFIBUS network. You do have the ability to, you've got a live list, which shows me a really quick indication that node number 9 is configured and not live. Node 10 is live and in data exchange. And node number 1 is this device, my DP master. You can also go in and discover nodes on a network. So you can go ahead and start the discovery, and it's going to show you each of the devices that are out on that PROFIBUS network. If a available option, you can actually upload the configuration from the device if the device supports that. And so that is an option that you just come over to this upload section, right mouse click, and you can do an upload configuration. And that'll pull back configuration from the device if the device supports it. And then the logic statistics, this is if you were doing any additional messaging that's not covered by the I/O connection, which I'm not doing for this right here. Another feature that I wanted to show is our DP packet capture. The DP packet capture allows you to actually go in and capture up to 10,000 PROFIBUS packets on a network. This can be very helpful if you're troubleshooting specific devices, maybe potential cabling or wiring issues. You got noise on the line, something like that. And so what we can see right here is just from our DP packet capture utility, we're sending a message to node number 9, not getting a response. We send a message to node number 10, we get a response. And then it also displays the data or the information that we're getting back from that particular device. So you can actually look at the PROFIBUS data packets in without any additional diagnostic tools. So that's one of the key features with troubleshooting on this module that could be very helpful. And I believe that's about all we had to discuss today. And if there's any questions, please feel free to contact our technical support team. They'd be more than happy to answer any questions you may have. Thank you for your time.